Good afternoon and welcome back to this explanation about non-supervised machine learning methods in which we're going to look at K-means, fuzzy, C-means, and Gaussian mixture model. It is important to mention that we're going to use the same data set for the three examples. And it is important also to mention that something that we want to do, or well, let the machine do when doing non-supervised machine learning is to do clustering. What does clustering means? Cluster means that you're going to separate the data points, the data that you have, into clearly defined groups, as we can see on the first image, where we have clearly this group, the second group, and a third group. We can see here clearly that the classification method has gone wrong, as this group, half of the group is green and the other half is blue. And that's why we want to use correct non-supervised machine learning methods. The first one of them will be K-means, in which you want to put a centroid or a reference point and you're going to measure the distance between the centroid and the data point. And the closest you are to the centroid, the most likely you will be from that data group. As we can see here, this data point is closer to the blue than to the green, that's why it is for the blue part. This was done incorrectly, that's why you have this part of here where this group is half blue and half green, not like here, that you have correctly placed the reference points, and that's why you have these three clear defined groups. We have seen in the example in here in which in two groups we can see orange group, blue group, the center points aligned for helping us to understand it better, and we can see that all this part of here is orange, all from here is blue. And we have a problem here. This data between here, if the model places incorrectly these points, there will be a problem. And the problem will be that data could be put on the other side incorrectly. This data may be blue and it was considered orange, or vice versa. And that's why fuzzy C-means exist, because fuzzy C-means don't want to hard cluster as in this example. It wants to soft cluster, and soft clustering means that you're not looking at data as it is white or black. You're looking at all the gray spectrum, and that's why we can see here clearly this data is blue, here clearly the data is orange, here is orange with influence from the blue, and here is blue with influence from the orange. Okay, and that's why we have this image. That is what you shouldn't do. You shouldn't do like hard clustering with fuzzy C-means. You can do it, it is not recommended. And what you want to do is soft clustering. Here you have clearly the blue group, clearly yellow group, but you have also these blue, cyan, teal, green colors that correlate to the mixture between the two groups. And that's what you want to do in here. Finally, you have the third method, that is Gaussian mixture model, and you want to look at three variables here. You want to look at mean, covariance, and weight for the final distribution. We're going to see here in an example that we have the mean, the center point that you're going to locate. You have it here for blue, red, and green. The covariance, you're looking at how far you're going to go from that point considering the mean and median, and you're going to look 1, 2, 3, or 4 in the covariance. You can go more. Finally, you're going to look at the weight, and that was the problem in this case. We give more weight to the blue side, and that's why the blue side overlaps above the red and green side. In the second example, we can see that clearly weights have been correctly given, means have been correctly placed, and the covariance means that the three groups don't overlap, and this makes that this group is cataloged as blue, this as red, and this as green. If we look at our example with two groups, we're going to look at that. We're going to look at blue group, we're going to look at orange group, clearly. We're here the mean, we have here the mean, the 1, 2, 3, 4, 5 lines of the covariance, 1, 2, 3, 4, 5 lines of the covariance, and finally the correctly weights. We have here some kind of overlaps, but it is solvable. We are going to compare now this between the images that we have obtained, and we can see, for example, in here, even when it's not recommended to do hard clustering fuzzy C-means, that we have orange, orange, blue for these 3 points, and we have here orange, blue, blue. That's because the two machine learning not supervised machine learning methods function differently. Obviously, you don't want to do hard clustering here, you want to do soft clustering, and that's why you have all this scale. And finally, the Gaussian mixture model, where we can see that this group was clearly orange, in this case blue, and here it has been put on the other side. And that's the difference between the different methods and why we need to adjust parameters correctly and precisely. Finally, it is important to mention that this is not only done for 2 groups, you can do it for more than 2 groups, you can do it for 3 groups, and it will work completely fine. Here we are going to do an example for k-means, 3 groups, you can do it completely fine. You can do it for 4 groups, there is no problem. It depends on how many groups you have to order. Thank you very much.